Video number 176, graphing the sine function. Graph y equals sine x. Let's look at the unit unit 1 circle, the 30-60 right triangle, and the right isosceles triangles. Let's take a look at those three things. And guys, you should be able to create those three things at any moment in time in your trigonometry careers, however short they are. You need to make the unit circle. Okay, there's unit circle. This is the point 1, 0. This is the point 0, 1. Negative 1, 0. 0, negative 1. We know the alphabet. Cosine, comma, sine. Cosine, comma, sine. Cosine, comma, sine. And so on. We also know that tangent equals opposite over adjacent. Therefore, it equals sine over cosine. Guys, you should be able to make the unit circle. You don't need to memorize it. You can create it. Then we need to also at some point create the 30-60 right triangle. Okay? It doesn't have to be perfect. You just have to know where the numbers go. The smaller angle is 30. The larger angle is 60. 1/2 is the sine of 30. Pythagorean theorem, square root of 3 for the longer leg. 45, 45, or in other words, the right isosceles triangle, 1, 1, Pythagorean theorem gives you root 2. This is not difficult stuff. Everyone should be able to do this. Even 6th graders, 4th graders could do this. Okay, bottom line, you can do it too. Here we go. Let's take a look at sine x. Now, looking at our unit circle, what's the sine of 0? 0. There you go. What's the sine of 45 degrees? That would be 1 over root 2. If you type it in the calculator, of course, you just get simply 0.707. We'll round it off to 0.71. Then we're going to look at sine of 90. That goes back to the unit circle, 1. And of course, you can type these in the calculator. Now, guys, let's go ahead and graph this. 0, comma 0. Okay? Pi over 4, comma 0.71. Now this is going to be 1 here. Now pi over 2, comma 1. There you are. Now pi over 4 is going to be 45. That's going to be halfway. Notice how you're 0.71. That's about. It's definitely more than half. See how that fits? Okay. Then we're back to 0.71 again when you go back to the other 45. This would be the 45 degree in the second quadrant. Right? Isn't it kind of neat how this is the first quadrant, second quadrant, third quadrant, fourth quadrant? Guys, this is really good times. Trigonometry is definitely good times. Okay? Now, sine of 180, 0, unitcircle.com. Alright? What do we got here? Pi, this is another one of those negative 0.7s. It's another one of those 45. This is a 45 degree where? Quadrant 3. This is 270, and this is quadrant 4's 45 degree angle. Pretty neat how all that works. Now, I just want to also point out to us that if we were to have stopped at 30 degrees, that would have been half. And obviously, if this is 45 degrees, 30 is going to be here, 60 is going to be here. Isn't this kind of neat here? Look at this. There's your half. That's about halfway. All right. 60 is 0.87. Guys, it's good times how this all works out. And it's really cool how everything over here is in the first quadrant. That's the second quadrant. That's the third. And that's the fourth. Okay. So this is what sine x looks like. Now, if you stick a 2 or a 5 or something in front of that, all it does is multiply everything in the range by that number. Okay, so that would have changed. Now, obviously, this would have put us here at from -1 to 1. What is the domain and range for y equal sine x? Domain is what? From 0 to 2 pi with an open parentheses. What's the range? The range would have been -1 to 1. Now, if we were to do 2 sine x, domain, same thing. We're going to go from 0 to 2 pi. But the range, what happens? All that's going to do is change your unit circle to having a radius not of 1, but of 2. It would make the circle larger. Okay? It would make the range twice as big. So we would go from -2 up to 2. Alright? So that's how all of that works out. Alright? So this is where we're headed here. We're going to be graphing sine, cosine, tangents, and some cosecants and everything else. So good times. If you have any questions or concerns, please send me an email. Talk to you later.